So जो modified Eulers है, that is y1 is equal to y0 plus h by 2 f of x0 comma y0 plus f of x1 comma y10. Okay.
सर यही टर्म में
So this is important thing to understand, that in Euler's method we don't have this. We directly write h into fx 0 comma y0. Okay. So this term is from Euler's. You calculate by Euler's method the value of y1. You can do that.
Yes, sir.
So in this notation, y0 is just simply
y0
h
plus
y0 plus h times f x0
y0.
comma y0.
Yes, sir.
Okay.
Yes, sir.
You get it from there and put it here. So we are just taking the average of this. So this y10 will be substituted here, and then you will take the average. So the difference between Eulers and modified Eulers is that in Eulers you directly write y10 is equal to y0 plus h fx0 comma
Yes, sir.
y0, and in modified Eulers you have to take average of these two quantities. One at initial point the value of the function, and another is at the point x1 with value y is equal to y10, which is coming from the Eulers.
Yes, sir.
So this is very important, and this is one of the main confusions. Okay, every time I teach this, there is a confusion. So this should be cleared. So clear to everyone?
Yes, sir.
Yes, sir.
Now in differential equation, I have the most important method which is used today is Runge and Kutta method to solve the differential equation. We have Runge Kutta method, and we have to actually discuss two methods: Runge Kutta of second order, which has error of the order of h cube, and Runge Kutta of fourth order, which has error s to the power 5, where h is the step size. Okay.
Yes, sir.
Now let us deal with this Runge Kutta method. So suppose we have a differential equation like this: dy by dx is equal to,
Sir, order means error.
order means second order and fourth order. There are two methods. In Runge Kutta method, there are two methods. First method is called second order Runge Kutta, and the next method is called fourth order Runge Kutta. Okay. So I will discuss them one by one. So dy by dx is equal to fx is your the differential equation, and let me explain you what I will be doing. Actually, at some x0 you will be knowing the value of y. What is the solution of this differential equation? What is the solution of this differential equation? Y?
Exponential.
Why is the solution of this differential equation?
Yes, sir.
Right?
Yes, sir.
So we know the value of y. So y is the solution. Please understand this, everybody. So simple thing, but we miss it. So y is the solution of this equation, and we know the value of y at x0. This is given. right? And at some point, say x1, we want this value which is y1. And also we can continue getting the values, different values, and this is called solution of the differential equation. Correct? So in Runge Kutta second order, this y1 and this is called step size. This is called h, which is called the step size. So in Runge Kutta second order, this y1 value is equal to, please understand this everybody, this is equal to y0 plus half of k1 plus k2. Okay, so this is the value of y1 in Runge Kutta second order. And important thing is, what is the value of k1 and k2? So k1 is simply h of f x0 comma y0, and k2 is, so please understand this will be calculated using the boundary condition. Yeah,
Yes, sir.
and this k2 will be h of f. Now you have to jump to x1, so that will be given by x0 plus h comma y0 plus this value k1. So it is iterative method. जब तक कि ये वैल्यू नहीं कैलकुलेट करते k1 की, तब तक k2 नहीं निकलेगा. So this is called Runge Kutta second order. So please understand, this x1 is nothing but x0 plus h. Once this value is calculated, the value of y1 at x1, the same iteration can be applied and we will get x2, y2 at x2 and hence so forth. इस तरीके से हम calculate करते चले जाएंगे. Okay? So this is called Runge Kutta second order. Everybody understand?
Yes, sir.
Try to understand this.
Sir, y2 should be y1 plus half k3 plus k4.
So now you don't need to, na? Suppose you want to get this, so treat this as initial condition. Say,
Okay, sir.
apply same thing. Suppose this was not there. This was there. So this is the initial condition and apply the same thing. Right?
Yes, sir.
So for y2, x1 and y1 act like initial
X0 and
values.
Y0.
Yeah, initial values. Is that fine? Second order Runge Kutta.
Yes,
Now
sir.
let us go for fourth order. So the fourth order Runge Kutta is like this. y1 is equal to y0 plus 1 by 6 k1 plus 2 k2 plus 2 k3 plus k4. So because of this presence of k1, k2, k3, k4, it is called fourth order. Okay. Now
Yes, sir.
let us write the value of k1, k2, k3, k4. So it is very symmetrical. You see, this 6 is because 1 plus 2 plus 2 plus 1. Kitna ho gaya? 6. Yes. So k1 will be h of f x0 comma y0. k2 will be h of f x0 plus h by 2 comma y0 plus k1 by 2. k3 will be h of f x0 plus h by 2 y0 plus k2 by 2. It is very symmetrical. And k4 will be h of f x naught plus h into y naught plus k3. You should have the feeling of this function fx comma y, fx comma y, fx comma y, fx comma y. So you must be knowing the
Sir,
concept of function. Yeah.
sir, here in the problem, I understood, sir, the value is given x naught and y naught. But in real life case, how can we find the x naught and y naught, sir? How can we find the x naught, sir?
So this is the initial condition. In real life also. Okay.
Okay, sir.
So it is initial condition. So in real life also this is initial condition. Suppose you are discussing a particle dynamics. That means this equation is say dv by dt, okay, is equal to some function. So you would be knowing that what is the value of velocity at t is equal to 0 when you have started observing the system. So
Okay.
that gives you the initial condition. So initial condition is the property of the system. That comes from the property of the system. Okay.
Okay, sir.
Yeah. So now we can take a equation and apply second order and fourth order Runge Kutta method. So see how simple is the Runge Kutta. अब सबको याद हो गया होगा.
थोड़ा थोड़ा सर.
Are you seeing the symmetry? 6, 1, 2, 2, 1. And then here x naught comma y naught. Here half, 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 and then here full. K1 is used here, K2 is used here, K3 is used here. Are you able to see the symmetry?
Yes sir.
So I will be taking, and please understand the concept of function. Any function is given, this will be going at the place of x, this will be going at the place of y. For example, here what is x?
x naught
Not
plus
plus
h by 2.
x naught plus h.
सर नीचे वाले ना सर.
अरे एरो नहीं देख रहे हो भाई?
यस सर.
अच्छा बताओ, मैं कहूँ व्हाट इज दिस तो तुम ये वाला बताओगे.
सर मुझे लगा आप ऊपर बना रहे थे.
अच्छा बताओ, ये दिल्ली है और ये एरो लगा हुआ है, तो दिल्ली किधर है?
सर
एरो के पीछे.
इधर है, इधर है दिल्ली.
नहीं सर, वो मैं जल्दी जल्दी देख ली.
कोई बात नहीं, मैं भी मजाक ही कर रहा हूँ. तो ये देख लो जरा, ये फंक्शन सबको पता होना चाहिए. अब जरा एक इक्वेशन लेते हैं और फटाफट रंगे कुट्टा सेकंड ऑर्डर और फोर्थ ऑर्डर अप्लाई कर देते हैं. तो कोडिंग करने में इसको बहुत मजा आता है जब आप पीछे वाली वैल्यू को आगे यूज करते हो.
यस सर, कर रखी है.
कर रखी है ना?
यस.
वेरी गुड. सो मैंने भी अपने काम के लिए एक्चुअली तो बने बनाए सब रूटीन्स होते हैं, बट समटाइम्स इट इज ऑलवेज बेटर टू राइट कोड फॉर योरसेल्फ, ताकि उसमें आपको हर बात पता होती है, तो आप जरूरत पड़ने पे बड़े आसानी से मॉडिफाई कर लेते हो, राइट?
यस.
सो dy by dx is equal to y minus x. मेरा तो बहुत मन है कि इस कोर्स के साथ 4-5 क्लासेस पाइथन की इंटीग्रेट कर दो, और जितनी जितनी प्रॉब्लम्स आप टेक्निक्स सिखा रहे हो उसके लिए आप न्यूमेरिकल सिमुलेशन भी सिखा दो ना. लेकिन
बहुत
फिलहाल
अच्छा रहेगा सर.
हाँ, लेकिन फिलहाल अभी तो पॉसिबल नहीं हो पाएगा इस वाले कोर्स में, बट जल्दी करते हैं. सो प्लीज सी दिस इज द इक्वेशन and this is given y0 is equal to 2 and I want y at 0.1. This is question mark. So let us do this. So first of all, let us do this for second order. सभी लोग calculator अपना ready रखो, and you all know there is a gate calculator present on the app also. on this
Sir, gate.
Google app, GATE calculator. So the same calculator that IITs use. So you all can download, and you please keep a scribble notebook with you, small notepad type की चीज होती है ना.
हाँ सर.
Whenever you are solving the question apart from your classwork, do it on that, so that वो आदत आपकी एग्जाम तक मेंटेन रहेगी. एग्जाम में भी वैसा ही पैड मिलता है आपको स्क्रिबल करने के लिए, राइट?
Yes sir.
सो ये छोटी छोटी चीजें दे गिव यू द कंफर्ट कि जब आप एग्जाम में जाते हो तो वो सेम टाइप की सिचुएशन, सेम कैलकुलेटर, सेम स्क्रिबल नोटबुक. बिकॉज अभी मान लो आप इतनी बड़ी बड़ी कॉपी रखे हुए हो सॉल्व करने के लिए, एंड अचानक जब वो छोटी नोटबुक मिलती है, इवन यू आर नॉट एबल टू सेटल योर हैंड राइटिंग ऑन दिस. So these small things matter a lot. Okay,
Yes.
चलो करते हैं ये क्वेश्चन. तो let us first of all apply the second order.
इसमें h नहीं दे रखा हम लोग.
अच्छा हम लोग ले लेते हैं ना, don't worry. So this is 0 and we want to calculate at 0.1 and here value is 2. Okay, so let us make ourselves very comfortable so that we will jump in one step to the value, right? But in real life we will not do this. We will make the small steps. So 0.1 is the step size. So what is the value of y1? Yeah, bolo bolo. y0
y naught
plus
plus
half
k1 plus
k1
k2.
plus k2. विदाउट सीइंग राइट इट. यहीं पे याद हो जाएगा आपको. ये कोर्स करते समय, ये चैप्टर करते समय आपको बाद में देखने की जरूरत सिर्फ रिवीजन पर्पस से पड़ेगी. अदरवाइज you will be able to understand everything. Now, what is the value of k1? Yeah, h of f
X naught y
x0
naught.
comma y naught. And by the way, what is fx comma y here?
0 comma minus 2.
Y minus x. What is fx comma y?
Yes sir. Y minus x.
Y minus s. So k1 will become h times y naught minus x naught. So it will become 0.1 times, what is y naught? 2 minus 0. So it will become 0.2. Okay, ठीक है भाई. And what is the value of k2? It is h times f
X naught plus h.
x naught plus h
Y naught plus K.
Y naught plus
y
k.
naught plus k1.
1.
So this will become 0.1 times y naught is 2. So 2.2 minus 0.1. Am I right? So this will become 0.21.
y1 is equal to 2.205.
Right? So what is y1?
2.205.
2.205.
y0 plus half of 0.2 plus 0.21. So that is equal to 2 plus half of 0.41. So 2.205. So it will become 2.205.
205.
So see, this can be a possible question in your exam. Just Runge Kutta second order. Right? Any doubt in this?
No, sir.
Yes.
No, sir.
Very good. Can I raise this?
Yes, sir.
So let us
Yes, sir.
apply. Let us take the same problem and apply fourth order. Everybody. So fourth order, you know, is y1 is equal to y0 plus 1 by 6 k1 plus 2k2 plus 2k3 plus k4. This is Runge Kutta fourth order. Okay.
Yes, sir.
Now get the value of k1, k2, k3, k4, everybody. Calculate k1 is just h of f x0 plus what is k1?
X0, Y0, sir.
What is this value?
0.2.
So k1 is 0.2. Then k2 h of f x0 plus h by 2 y0 plus k1 by 2.
0.205.
सभी लोग करो फटाफट and just keep correlating.
Sir, K3 is 0.20525.
Yeah. And k3 is
0.20525.
20525. Absolutely.
Sir,
And k4
sir, 0.210.
53. This is k4.
0.21057.
53 आ रहा है.
Sir,
So the value of y1,
10
which is y at 0.1, is, apply the formula, 2.2052. So everybody do all the steps. Calculate k1, k2, everybody. If there is any problem, please ask. Do it patiently. Clear है भाई सबको?
Yes, sir.
Everybody
Yes, sir.
got these values k1, k2, k3, k4.
Yes, sir.
And if you want y at 0.2, what you will do?
इसमें put कर देंगे sir. Y1 में. Y1 equals to Y0 plus 1 by 6.
No. If you want y2, just again take the value like this. Take it 0.1. Take it 2.02052. This is your new x0. This is your new y0. Again apply, again calculate y1. Don't do anything else. Understood it or not?
एक बार
सर
और
मतलब
बताइए
नेक्स्ट
सर।
वैल्यू के लिए
अरे भाई
y1 y
जो तुमने कैलकुलेट किया x0 और y0 पता था,
हाँ सर।
तो
Yes,
x1
sir.
y1 निकाल लिया।
यस सर।
तुम्हें x0 y0 के हिसाब से सारा फॉर्मूला पता है,
यस सर।
पता है ना,
Yes.
y1 इज इक्वल टू।
yes sir.
अब मैं कह रहा हूं तुम चाहो तो y2 वगैरह में जाओ ही मत। अगेन राइट अ न्यू प्रॉब्लम दैट आई हैव बीन गिवन 0.1 and 2.2052. Suppose this is new problem. x0 is this much and y0 is this much. Okay. Then again apply the same formula to get y1. What you will get here? 0.2. And here you will get new value. Yes or no?
यस सर।
Yes sir.
So whatever new, and then again make it x naught y naught, and again, so in that way you can just keep on iterating and getting the new values. सबको समझ आया ये बात?
हाँ सर।
Everybody understood this? Tell me भाई.
यस सर। सर इसको मतलब 2 स्टेप्स का रखना है कोशिश करके।
तो फिर आपका सिर्फ 2 ही स्टेप रहेगा ना हमेशा.
यस सर।
So whatever new value you get, make it initial value and apply the same y1.
यस सर।
Yes, Sautan, is that okay? Okay. So this was your Runge Kutta method, second order and fourth order. This is one of the very popular methods in numerical technique. So all the solvers, main solvers of every software like MATLAB, they use in the background this Runge Kutta method to solve the differential equations. Okay.
तो डिफरेंशियल इक्वेशन सॉल्व करने में सबसे एक्यूरेट मेथड भी रंगे कुट्टा मेथड ही है.
हाँ, because it's to the power 5 है. So if you reduce the step size sufficiently, then you can make the error really very, very small. Okay. So now one very important method is finite difference method. This is the method in which understanding of grid will come to you, how we make grids and how we solve. So especially all the partial differential equations nowadays, they are solved using finite difference method. And because here, you know, a simple routine is there. How we define the grid, please understand this. Like suppose you have some xi minus 1 value, and you have the value yi minus 1 for that. A grid is running, so this is some value, and here it is xi and yi, right? For some ith value. And then here the grid will increase, it will become i1 plus I plus 1 and yi plus 1. You can take an example. If I is equal to 1, it will become x0, x1, x2. It will become y0, y1, y2. Understood? For any differential equation, this will be the grid. Okay. So now finite, in the background of finite difference method, there is Taylor's method, but I will not go into the derivations. I will just write for you what are the values of this second order derivative and first order derivative. So if I write y dash, what is the value? So suppose I write it between this. So what I will get is, बताओ भाई क्या आएगा? If h is
yi minus
the step size, what I am going to get is
yi
yi
minus
plus 1 minus yi minus 1 over 2h. Correct?
Yes, sir.
And y double dash, these derivations are done using Taylor's expansion. I am not going into that. So just you will have to remember it for little bit. Okay. So this will be yi minus 1 minus 2h plus yi plus 1 over h square. So these are the value of derivatives in terms of this grid. Please see this. So how this is written in the background, it's Taylor's expansion. You can see nothing is escaped out of this Taylor's expansion. Yeah.
Yes, sir.
ये समझ में आया? थोड़ा सा समझ आ रहा है ना कि इन दोनों का डिफरेंस अपॉन द ग्रिड लेंथ. ये फर्स्ट भाई डेरिवेटिव तो ऐसे डिफाइन करते हो ना जो आप क्लास 11th में डिफाइन करते हो कि
हाँ, सर.
f dash of x is fx plus h minus fx upon h. Okay, something like this. So but this is done using Taylor's expansion, तो ये डायरेक्ट नहीं है. हाँ बताओ भाई.
सर वो सेकंड वाला डेरिवेटिव नहीं समझ आता मतलब.
अब ये इसका डेरिवेशन मैं नहीं कह रहा हूँ. If you
जी,
want to see the derivation, please see the page number 326 of SAS 3.
Okay, sir.
If you want to go into the derivations, but in numerical technique we will not go into the derivations. Okay.
सर ये डेरिवेटिव तो समझ में आया पर सर ये ग्रिड समझ में नहीं.
अरे ग्रिड बस शब्द ही बहुत फैंसी है, कुछ नहीं है ग्रिड. तुमने यहां से शुरू किया,
यस सर.
कूद के यहाँ गए, कूद के यहाँ गए, इसी को ग्रिड कहते हैं. ठीक है. इन सब के बीच का गैप h है. यहाँ पे वैल्यू x0 थी, यहाँ x1 कह दिया, यहाँ x2 कह दिया. तो अगर ऐसे ही पूरे स्पेस में चलती चली जाए तो इसी को ग्रिड कह देते हैं. ओके. ये हो जाएगा y0, ये हो जाएगा y1, ये हो जाएगा y2. तो इसी तरीके
xi माइनस 1 की जगह x0 भी ले सकते.
सॉरी
सर आपने जो xi माइनस 1 लिखा है,
हाँ,
उसकी जगह x0 भी कंसीडर कर सकते हैं.
अब ये तो बहुत ही बेवकूफी वाली बात हो जाएगी. आई लिखने का मतलब ये है कि अब 1 करोड़ तक चलते चले जाओ. चाहे आई क्यों लिखा जाता है? जैसे मान लो तुम समेशन आई लिख देते हो तो तुम कह रहे हो कि इस आई की जगह 1 लिख दूं. आई का मतलब ये कि तुम्हारे पास लिबर्टी है ना कितना भी समेशन को चलाने की. समझ रहे हो कि नहीं?
यस.
तो जैसे ही तुमने आई लिखा, अब आई को रन कर दोगे तो ग्रिड चलता चला जाएगा. समझ रहे हो कि नहीं
यस
वरुण?
सर.
हम्म.
यस सर.
लेकिन अगर मैं ये तो मैं समझाने के लिए बोल सकता हूं ना.
यस.
बट अगर जनरल लिखना होगा तो ऐसे लिखना पड़ेगा ना ग्रिड को. राइट.
जी सर.
तो अब तुम आई को रन करो, आई को 0 से शुरू करके 10 तक कर दो तो 10 तक की ग्रिड बन जाएगी.
यस सर.
तो सारे x0 की वैल्यूज पे y0, y1, y2 ये सारी वैल्यूज. अब देखो जरा, ये बहुत ही इंटरेस्टिंग है. अब इसमें मैं एक इक्वेशन ले रहा हूं क्योंकि ये सबसे मजेदार है कि अगर मैं आपको एग्जांपल से बताऊं तो बहुत ही अच्छे से समझ में आ जाएगा, अदरवाइज समझ में नहीं आएगा. मान लो कि कोई डिफरेंशियल इक्वेशन है y डबल डैश प्लस y प्लस 1 इज इक्वल टू 0 एंड 0 x लेस देन 1 में मुझे सॉल्व करना है. एंड कंडीशंस आर गिवन y0 is 0 and y1 is also 0. Okay, and the value of h is 0.5. This is a very tough differential equation to solve. इसका exact solution जो है इस differential equation का बिकले ने 1968 में दिया था. And the solution is like this: yx is equal to cos x plus 1 minus cos 1 over sin 1, and in this bounded region into sin x and minus 1. This is the solution given to this equation. Okay, we can solve
तो
this.
1 minus cos 1 लिखा है.
Sorry, 1 minus cos 1. That is
Okay.
coming from the boundary condition, no? But we don't have to bother about this solution. मिटा दूं इसको?
Yes, sir.
Sir, एक minute, sir. Yes.
We have to do it numerically using
Finite difference method.
finite difference method. So please understand the grid. Grid is like this. The value is to be calculated between 0 and 1. And since they have given the grid size 0.5, सबसे पहले वैल्यू मैं कहाँ निकाल पाऊंगा? 0 पे 0 है और 1 पे भी 0 है और 0.5 पे मैं निकाल लूंगा फाइनाइट डिफरेंस यूज करके. समझ रहे हो कि नहीं पूरी बात?
हाँ सर.
So the value is 0 पे 0, 1 पे 0, 0.5 पे unknown that I want to calculate. So let us apply this method. H is equal to 0.5 hai. So we will immediately come to 0.5. So y double dash is I plus 1 minus, sorry, I minus 1 minus 2h plus I plus 1 by h square plus y. Y is yi, right? Plus 1 is equal to 0. This is the equation. Please see it. Okay.
Yes,
So
sir.
now this is your iterative equation. Every value is given. So if I take I is equal to 1, because you know you will jump immediately to this. So it will become y0 minus 2h plus y below 2.
Y.
I is equal to 1 na?
Yes, sir.
Upon h square plus y1 plus 1 is equal to 0. So this is x0, this is y0, this is x1, this is y1, this is x2, this is y2. So this value is to be calculated. What is that value? y1. क्या है value? This value. So you can see y0 is 0, y2 is also 0 according to the boundary condition. So tell me what is the value of y1 quickly.
Sir, 3.
2 by h minus 1.
0.139.
What? So this h and h.
Sir,
So-
3. Y1 equal to.
No, wrong.
So 1.
So y1 will be equal to, please see this. यहाँ पे क्या बच जाएगा? 2 by
1 by
h.
h minus 1.
2 by h minus 1. 1 by h कैसे भाई?
No, is it 2 by h? Yes.
Minus 1. So this will be 0.5.
Yes, sir.
Just wait. There is some mistake.
3 सर यस 3 आएगा.
Hmm? Two minus yi minus 1 minus 2 oh just wait ये -2 this is why I am very sorry मैंने by mistake ये लिख दिया -2yi see I minus 1 I and I plus 1 -2yi please correct this in the original equation so this is -2yi and this will become y1 right
Yes, sir.
now calculate it so it will become this is 0 this will be h square right so it will be now put the values
0.25.
actually. क्या आएगी वैल्यू -2y1 अपॉन h स्क्वायर 0.25 प्लस y1 प्लस 1 इज इक्वल टू 0 तो ये तो इसको मैं 1/4 लिख सकता हूं ना
Yes, sir.
so -7y1
equal to -1.
is equal to -1 so y1 is equal to 1/7 this is correct answer
Yes, sir.
so understood the grid we have taken very simple h is equal to 0.5 but in real life you will not do this you will take smaller and smaller grids right
Yes, sir.
Ye,
0.14285.
so what is the value of y1
0.1428.
1428 okay and the actual value from the equation that I gave you comes out to be 0.1394 actual solution okay so they can just ask you to calculate the percentage error for this grid
Yes, sir.
but in real life actually we will make more grids like here only 2 was there I will take the value of h is equal to 0.25 I give you as a homework to write the equations so now linear equation will start forming in first case only one equation was there now if you take the grid size 0.25 then what will happen you wanted value at 0.5 but you took more grids so this will become x0 x1 x2 x3 and x4 can you see that
Yes, sir.
now these two values you already know this value you want to calculate so now what value you want to calculate y2 this is y1 this is y3 and this is y4 which is known ये ग्रिड बनाना सीख जाओ तो बहुत ज्यादा प्रोग्रामिंग में हेल्प हो जाती है everybody understood this now what is
Yes,
the h value
0.25.
0.25 तो ये मैं होमवर्क दे रहा हूं इसके हेल्प से जब आप ये इक्वेशन लिखोगे तो अभी देखो क्या करना पड़ेगा पहले लोगे i is equal to 1 ओके
Yes, sir.
and you will make a equation. तो equation कहाँ तक आएगी? I is equal to 1 पे y0, y1, y2, right?
Y2.
Because लेकिन यहाँ तो y4 तक है. तो next value you will assign. So first of all you will take I is equal to 1, then you will take I is equal to 2. Then it will become y1, y2, y3. Okay? And then you will take I is equal to 3. So it will become y2, y3, y4. So now 3 equations will be formed and 3 variables are there. They will be solved. These are the 3 variables. And 3 questions will be formed and they can be solved. समझ आ गया भाई?
Yes, sir.
हाँ sir.
So this will be homework. Do this and again calculate the value of this y2 because we wanted value at 0.5. It is now y2 in this grid. So calculate the value of 0.5. Okay. Thank you.
Thank you, sir.
Thank you,
Is
sir.
there any doubt?
सर
चलो,
लास्ट लाइन आप क्या बोला सर 0.5 से
मैं कह रहा हूं कि वैल्यू तो अभी भी वही निकालनी है ना. क्वेश्चन सेम है. 0.5 पे आपको y की वैल्यू निकालनी है. तो
उसके सर
पहले केस में जो y1 था अब वो क्या बन गया है? नए
Y2.
ग्रेड में y2 बन गया है. ओके.
Yes, sir.
चलो.
ठीक है थैंक यू सर
सर
Thank you, sir.
या
सर ये सारी प्रॉब्लम